Hello everyone, today we are going to explore the concept of limits, a fundamental idea in calculus that helps us understand the behavior of functions as the input approaches a particular value. We will look at limits involving three types of functions: polynomial, rational, and radical functions. For each, I will explain the key concept and rules before demonstrating how to solve an example accurately. Polynomial limit. A polynomial function is a function of the form where the coefficients are real numbers and the exponents are non-negative integers. Polynomials are continuous for all real numbers. Limit of the quantity of 3x squared minus 5x plus 4 as x approaching 2. Since polynomials are continuous, we can evaluate this limit by direct substitution. So we change x with 2. So all the x term will change to 2. So 3 times 2 squared minus 5 times 2 plus 4. So 2 squared is 4. Minus 5 times 2 is 10. 3 times 4 is 12. Minus 10. 2 plus 4 equals 6. Thus, the limit of this polynomial as x approaching 2 is 6. A rational limit. A rational function is a quotient of two polynomials where, when evaluating the limit of a rational function, if direct substitution yields a non-zero denominator, the limit is simply the value obtained by substitution. If it gives an indeterminate form 0 over 0, we use algebraic factorization or simplification to resolve it. Limit of the quantity of x plus 1 squared times the quantity of x minus 1 over x cubed plus 1 as x approaching 1. So the first thing we will do is factor out the denominator by the sums of cubes. So x plus 1 with the trinomial x squared minus x plus 1. So the form, the denominator factored out cube form is quantity of x plus 1 times quantity of x squared minus x plus 1. The next step is the quantity of x plus 1 squared we will factor out into binomial. So how to do it is like this: x plus 1 and x plus 1. So the form of binomial of x plus 1 squared is quantity of x plus 1 times quantity of x plus 1. Now the expression becomes quantity of x plus 1 times quantity of x plus 1 times the quantity of x minus 1 over the new trinomial factored out, quantity of x plus 1 times the quantity of x squared minus x plus 1. Now we will do some cancelling method whose terms are common or similar. For example, the quantity of x plus 1, the numerator and denominator, so we'll cross it out. Now, our form will be left by quantity of x plus 1 times x minus 1 over x squared minus x plus 1. Now we will substitute the x as 1. So 1 plus 1 times quantity of 1 minus 1 over 1 squared minus 1 plus 1. 1 plus 1 is 2, 1 minus 1 is 0, 2 times 0 is 0. 1 squared is 1, minus 1, 0 plus 1 is 1. Thus, the limit of this rational as x approaching 1 is 0. A radical limit. A radical function involves roots of expressions, such as the square root. When solving limits with radicals, the key principle is to isolate the radical and, if necessary, eliminate it by squaring both sides while being careful with domain restrictions. Limit of the square root of x plus 5 minus 3 over x minus 4 as x approaching 4. So the first method we will do is the direct substitution, which we changes the x to 4. So square root of x changes to 4, so 4 plus 5 minus 3 over 4 minus 4. 4 plus 5 is 9, so the square root of 9 is 3. 3 minus 3 is 0. 4 minus 4 is also 0. 0 over 0 is an indeterminate form, so it cannot be. Find the limit of this radical. To resolve it, we will use the conjugate method. We will multiply the numerator and the denominator of the conjugate of the numerator, square root of x plus 5 minus 3. So we will rewrite the form. Square root of x plus 5 minus 3 over x minus 4. So to do the conjugate form, the radical sign will remain the same, but the whole number sign will change into the opposite of it. So multiply square root of x plus 5 plus 3. So what we did is we changed the sign of the number 3 into its opposite. So we will write the denominator also. Square root of x plus 5 plus 3. So the next method will be hard, but bear with me. So the next one we will do first to the numerator. So we simply copy the quantity of x minus 4 times the quantity of square root x plus 5 plus 3. For our numerator, we will simply square every term of it. So square root of x squared plus 5 squared. Negative times positive equals to negative. So negative 3 squared. So let's do the denominator first. So simply copy the quantity of x minus 4 times the quantity of square root x plus 5 plus 3. For the numerator, we will multiply the two conjugates. So square root of x times x is x squared. 5 times 5 is plus 25. And negative 3 times positive 3 is negative 9. So the next step, we will take the square root of x squared plus 25. So it will be left with x plus 5 minus 9 over x minus 4, quantity of x plus 5 plus 3. So next step is we will add the numerator. So 5 minus 9 is equals to negative 4. So x minus 4 over quantity of x minus 4 over the square root of x plus 5 plus 3. At this point, we can cancel the two similar terms, which is x minus 4 in the numerator and denominator. So cross it out. This time, we are left with square root of x plus 5 plus 3. Now we will simply input our x, which is x changes to 4. So square root of 4 plus 5 plus 3. So 4 plus 5 is 9. Square root of 9 is 3. 3 plus 3 is 6. So the answer is 1 over 6. Why the answer become 1 over 6. When we cancel the x minus 4 on the numerator and denominator, the numerator was left with the whole number of 1. So in tally, it will be 1 over quantity of square root of x plus 5 plus 3. So the numerator should only have a 1. And so the answer is, thus the limit of this rational of x approaching 4 is 1 over 6 or 1/6. In summary, limits allow us to understand how functions behave near specific points. For polynomials, we use direct substitution. For rational functions, we factor and simplify if needed. And for radical functions, we carefully isolate and apply continuity or algebraic manipulation. By mastering these techniques, we can confidently evaluate limits across a wide range of functions. Thank you.